Good day students. I'm Lloyd, your AI narrator of this subject aircraft material, construction, and repair 2, AMT 211. This is a short video that covers the prelim and midterm topic, so please take note of some important details or have a copy because, after this short slide, there are questions to answer serve as your attendance. This subject covers the sheet metal construction and non-metallic structures include the design philosophies of structure, factors affecting sheet metal part and joint design fundamentals calculations for structure and types of materials, hardware, tools, and equipment to be used. Inclusive in this subject the advanced composite materials and procedural repair of bonded composite materials. The satisfactory performance of an aircraft requires continuous maintenance of aircraft structural integrity. It is important that metal structural repairs be made according to the best available techniques because improper repair techniques can pose an immediate or potential danger. The reliability of an aircraft depends on the quality of the design, as well as the workmanship used in making the repairs. The design of an aircraft metal structural repair is complicated by the requirement that an aircraft be as light as possible. If weight were not a critical factor, repairs could be made with a large margin of safety. In actual practice, repairs must be strong enough to carry all of the loads with the required factor of safety, but they must not have too much extra strength. For example, a joint that is too weak cannot be tolerated, but a joint that is too strong can create stress risers that may cause cracks in other locations. Aircraft structure, construction, and repair 2. The repair discussed in this chapter are typical of those used in aircraft maintenance and are included to introduce some of the operations involved. Structural repair can be classified as corrosion repair, modifications, interior cabinet, stainless steel container repair fabrication and part fabrication. Damage to metal aircraft structures is often caused by corrosion, erosion, normal stress, and accidents and mishaps. Sometimes aircraft structure modifications require extensive structural rework. For example, the installation of winglets on aircraft not only replaces a wingtip with a winglet, but also requires extensive reinforcing of the wing structure to carry additional stresses. Structural repair involves modification, welding, composites. Structures designate engineering representative. Aircraft fuel tank bladder repair. Airport ground equipment repair. Numerous and varied methods of repairing metal structural portions of an aircraft exist, but no set of specific repair patterns applies in all cases. The problem of repairing a damaged section is usually solved by duplicating the original part in strength, kind of material, and dimensions. To make a structural repair, the aircraft technician needs a good working knowledge of sheet metal forming methods and techniques. In general, forming means changing the shape by bending and forming solid metal. In the case of aluminum, this is usually done at room temperature. All repair parts are shaped to fit in place before they are attached to the aircraft or component. Aircraft structural stresses. Stresses are the load per unit area imposed on the aircraft surface. The primary factors to consider in aircraft structures are strength, weight, and reliability. These factors determine the requirements to be met by any material used to construct or repair the aircraft. Airframes must be strong and light in weight. An aircraft built so heavy that it couldn't support more than a few hundred pounds of additional weight would be useless. All materials used to construct an aircraft must be reliable. Reliability minimizes the possibility of dangerous and unexpected failures. There are 5 basic stresses acting on an aircraft. Tension. Tension is defined as pull. It is the stress of stretching an object or pulling at its ends. Tension is the resistance to pulling apart or stretching produced by two forces pulling in opposite directions along the same straight line. For example, an elevator control cable is in additional tension when the pilot moves the control column. Compression. If forces acting on an aircraft move toward each other to squeeze the material, the stress is called compression. Compression is the opposite of tension. Tension is pull, and compression is push. Compression is the resistance to crushing produced by two forces pushing toward each other in the same straight line. For example, when an airplane is on the ground, the landing gear struts are under a constant compression stress. Torsion. Torsional stresses result from a twisting force. When you wring out a chamois skin, you are putting it under torsion. Torsion is produced in an engine crankshaft while the engine is running. Forces that produce torsional stress also produce torque. Shear. Cutting a piece of paper with scissors is an example of a shearing action. In an aircraft structure, shear is a stress exerted when two pieces of fastened material tend to separate. Shear stress is the outcome of sliding one part over the other in opposite directions. The rivets and bolts of an aircraft experience both shear and tension stresses. Bending. Bending is a combination of tension and compression. For example, when bending a piece of tubing, the upper portion stretches and the lower portion crushes together. The wing spars of an aircraft in flight are subject to bending stresses. The other type of stress is bearing. Bearing stress resists the force that the rivet or bolt places on the hole. As a rule, the strength of the fastener should be such that its total shear strength is approximately equal to the total bearing strength of the sheet material. Aircraft structure, material. An aircraft must be constructed of materials that are both light and strong. Early aircraft were made of wood. Lightweight metal alloys with a strength greater than wood were developed and used on later aircraft. Materials currently used in aircraft construction are classified as either metallic materials or non-metallic materials. Metallic materials. Most common metals used in aircraft construction are aluminum, magnesium, titanium, steel, and their alloys. Non-metallic materials. In addition to metals, various types of plastic materials are found in aircraft construction. Some of these plastics include transparent plastic, reinforced plastic, composite, and carbon fiber materials. Metallic materials. Alloys. An alloy is composed of two or more metals. The metal present in the alloy in the largest amount is called the base metal. All other metals added to the base metal are called alloying elements. Adding the alloying elements may result in a change in the properties of the base metal. For example, pure aluminum is relatively soft and weak. However, adding small amounts or copper, manganese, and magnesium will increase aluminum's strength many times. Heat treatment can increase or decrease an alloy's strength and hardness. Alloys are important to the aircraft industry. They provide materials with properties that pure metals do not possess. Aluminum. Aluminum alloys are widely used in modern aircraft construction. Aluminum alloys are valuable because they have a high strength-to-weight ratio. Aluminum alloys are corrosion resistant and comparatively easy to fabricate. The outstanding characteristic of aluminum is its lightweight. Magnesium. Magnesium is the world's lightest structural metal. It is a silvery white material that weighs 2/3 as much as aluminum. Magnesium is used to make helicopters. Magnesium's low resistance to corrosion has limited its use in conventional aircraft. Titanium. Titanium is a lightweight, strong, corrosion-resistant metal. Recent developments make titanium ideal for applications where aluminum alloys are too weak and stainless steel is too heavy. Additionally, titanium is unaffected by long exposure to seawater and marine atmosphere. Steel. Alloy steels used in aircraft construction have great strength, more so than other fields of engineering would require. These materials must withstand the forces that occur on today's modern aircraft. These steels contain small percentages of carbon, nickel, chromium, vanadium, and molybdenum. High-tensile steels will stand stress of 50 to 150 tons per square inch without failing. Such steels are made into tubes, rods, and wires. Another type of steel used extensively is stainless steel. Stainless steel resists corrosion and is particularly valuable for use in or near water. Non-metallic materials. Transparent plastic. Transparent plastic is used in canopies, windshields, and other transparent enclosures. You need to handle transparent plastic surfaces carefully because they are relatively soft and scratch easily. At approximately 225 degrees Fahrenheit, transparent plastic becomes soft and pliable. Reinforced plastic. Reinforced plastic is used in the construction of rod arms, wing tips, stabilizer tips, antenna covers, and flight controls. Reinforced plastic has a high strength-to-weight ratio and is resistant to mildew and rot. Because it is easy to fabricate, it is equally suitable for other parts of the aircraft. Reinforced plastic is a sandwich-type material. It is made up of two outer facings and a center layer. The facings are made up of several layers of glass cloth, bonded together with a liquid resin. The core material, center layer, consists of a honeycomb structure made of glass cloth. Reinforced plastic is fabricated into a variety of cell sizes. Composite and carbon fiber materials. High-performance aircraft require an extra high strength-to-weight ratio material. Fabrication of composite materials satisfies this special requirement. Composite materials are constructed by using several layers of bonding materials, graphite epoxy or boron epoxy. These materials are mechanically fastened to conventional substructures. Another type of composite construction consists of thin graphite epoxy skins bonded to an aluminum honeycomb core. Carbon fiber is extremely strong, thin fiber made by heating synthetic fibers, such as rayon, until charred, and then layering in cross-sections. Aircraft structural repairs. While making a structural repair, following parameters should be maintained as original: the structural strength, the design, safety standards, and cosmetic appearance. A perfect repair may reduce further cracks. Work stands used to ensure the proper maintenance of the aircraft. Platforms are designed to allow easy access to all aircraft service zones and difficult-to-reach areas. Aircraft structural members are designed to perform a specific function or to serve a definite purpose. The primary objective of aircraft repair is to restore damaged parts to their original condition. Very often, replacement is the only way this can be done effectively. When repair of a damaged part is possible, first study the part carefully to fully understand its purpose or function. Strength may be the principal requirement in the repair of certain structures, while others may need entirely different qualities. For example, fuel tanks and floats must be protected against leakage, cowlings, fairings, and similar parts must have such properties as neat appearance, streamlined shape, and accessibility. The function of any damaged part must be carefully determined to ensure the repair meets the requirements. An inspection of the damage and accurate estimate of the type of repair required are the most important steps in repairing structural damage. The inspection includes an estimate of the best type and shape of repair patch to use, the type, size, and number of rivets needed, and the strength, thickness, and kind of material required to make the repaired member no heavier, or only slightly heavier, and just as strong as the original. When investigating damage to an aircraft, it is necessary to make an extensive inspection of the structure. When any component or group of components has been damaged, it is essential that both the damaged members and the attaching structure be investigated, since the damaging force may have been transmitted over a large area, sometimes quite remote from the point of original damage. Wrinkled skin, elongated or damaged bolt or rivet holes, or distortion of members usually appears in the immediate area of such damage, and any one of these conditions calls for a close inspection of the adjacent area. Check all skin, dents, and wrinkles for any cracks or abrasions. Basic principles of sheet metal repair. The first and one of the most important steps in repairing structural damage is sizing up the job and making an accurate estimate of what is to be done. This sizing up includes an estimate of the best type and shape of patch to use, the type, size, and number of rivets needed, and the strength, thickness, and kind of material required to make repaired member no heavier, or only slightly heavier, and just as strong as the original. Also inspect the surrounding members for evidence of corrosion and load damage so that the required extent of the clean-out of the old damage can be estimated accurately. After completing the clean-out, first make the layout of the path on the paper, then transfer it to the sheet stock selected. Then, cut the chamfer the patch, form it so that it matches the contour of that particular area, and apply it. Examine the damage visually, the load damage, the supporting structural members, closely for partially failed rivets, for elongated holes, for corrosion damage and the white crystalline deposits around the loose rivets. Evaluate the damage location, the extent of the damage and the clean-out area. Plan the repair scheme, the type of material, rivet type and quantity, rivet pattern, duration and skilled personnel. Estimate the material cost, the required man-hour, the profit loss due to grounded aircraft. To execute, clean the damage area, cut out the corners into oval or circular shape, make a template using paper, select the appropriate material, identify the rivet pattern and rivet the material to the structure. First thing first, safety. In repairing structural damage, protect yourself first from risk and hazard by wearing PPE. Safety gloves. Safety goggles. Aviation earmuffs or earplugs. Safety shoes. Safety hats. Safety harness when working at heights. Without modern metalworking tools and machines, the job of the airframe technician would be more difficult and tiresome, and the time required to finish a task would be much greater. These specialized tools and machines help the airframe technician construct or repair sheet metal in a faster, simpler, and better manner than possible in the past. Powered by human muscle, electricity, or compressed air, these tools are used to lay out, mark, cut, sand, or drill sheet metal. Check this video of tools for sheet metal and repair.
Hello guys, today we're gonna do a quick basic aircraft tool familiarization. Let's start with torque wrench. Is a tool used to apply a specific torque value to a fastener such as a nut or a bolt. Next one is our files. As you can see, we have different types of file. We have the flat and the round. Files is an important but often overlooked tool used to shape metal by cutting and abrasion. They are used for smoothing the edges and the corners of a metal. Straight snip have straight blades with cutting edges sharpened but 85-degree angle. Aviation snips are used to cut holes, curved parts, round patches, and doublers in sheet metal. Cleco fasteners. Cleco fasteners comes with different sizes. Clecos are a type of fasteners. So the equipment that we use for the installation of Clecos is we have our Cleco flyer, of course. This is for the installation and uninstallation and removal of Clecos. C-clamps. C-clamps is shaped like a large letter C, as you can see, and has three main parts: threaded screw, jaw, and swivel head. Next we have our pneumatic rivet guns. Most common rivet upsetting tool used in airframe repair work. It operates in air pressure, so that's what pneumatic means. Rivet headers or rivet set. Rivet headers are made with short, offset, and long that brought close to work due to structural interference. So this is what we use for universal, and this is what we use for flush. And it comes with safety springs. So this is what we use for universal set. This is what we use for flush. And next, let's go to our bucking bars. Bucking bars, sometimes called a dolly, bucking iron, or bucking block, is a heavy chunk of steel whose counter vibration during installation. So this helps with the installation of rivets in airframe. Next, let us move to our angle drill motors. Heavy-duty right-angle drills are equipped with a chuck similar to the pistol grip drill motor. The drill bits that we use for an angle drill is threaded, as you can see. And of course, drill bits comes with different sizes as well. Let's move to our pneumatic drill motors or pneumatic drill gun. Pneumatic drill motors are the most common types of drill motors for aircraft repair work. They are lightweight and have sufficient power and good speed. And we use our chuck key for the installation and removal of our drill bits. We have our drill bushing or drill guide, as some call it. Also known as a jig bushing, is a tool used in metalworking jigs to guide cutting tools, designed to guide precision and support the cutting tool. It's also used to guide the drill to get the 90 degree. And next is our drill stop. There you go, our drill stop. Drill stop is a wire investment. It can be made from tubing, fiber rod, or hard rubber. There we go. Let's move to our micro stop. Micro stop is used for the installation of countersunk rivets. And as you can see here, there's a bit inside. This is what it looks like. This is what you use for countersinking. There we go. Die grinder is a handled tool that turns a mounted cutoff wheel, rotary file, and the sanding disc at high speed. Our rotary files, there you go. This is what we put on the die grinder. Cutting wheel. So we have here our rubber mallet. It is used for forming various sheet metal, variety of tools and equipment. There we go. Over here, we have our measuring equipments. So these three are used for measuring. We have here our steel ruler, our lock bolt grip gauge, and our caliper. Rivet cutters. Rivet cutters is used to trim rivets when rivets required length is unavailable. Pin punch is a straight shank characterized by a hexagonal body. Can you see that? There we go. So here we have our bench vise. Another clamping device that holds the workpiece in place and allow work to be done with saws and drills. Alright, and last but not the least, we have our pneumatic pup rivet gun. So that's it for our basic aircraft tools familiarization.